There are dozens of statistical packages available nowadays. While the basic functionality is nearly always the same, there are also some remarkable differences between them. Those differences might be crucial in how useful they will be in your future work. Learning a statistical package or a language takes significant time. Choosing the right one or ones gets you positioned correctly on the job market and saves your time and energy. In this lecture, I will tell you anything you need to know to make the right decision in choosing a statistical package and investing your time. So what is a statistical package? Basically, when I talk about the statistical package, I mean the software or language you are using to manipulate, clean, enter, or plot data. Basically, any data manipulation is made in a statistical package of some sort. It can either be a whole programming language like R, or it is more like a convenient click interface like the SPSS software. No matter if it is a convenient software or a language, the things you can do are quite the same. Excel could be seen as a statistical package. You can plot graphs, you can do data management, data cleaning, and even simple statistical tests. When it comes to the first steps like data insertion, it is still a very useful software and any data scientist should be able to use it in a very advanced level. It is the stats software used and understood by most employees worldwide. Hence, if you work in a team with non-data scientists, you can communicate and transfer data easiest via Excel. Should you have an assistant, let him do the easy data manipulations in Excel instead of having him struggle with R or Python for weeks. So what are the key functionalities of nearly any statistical package? Well, all advanced full-service statistical packages should be able to perform data management tasks like cleaning, changing, deleting, or checking the data. It should also be able to do statistical analysis, including modeling and predictions. And data simulation would also be a very cool feature. We also need data visualization skills like data plotting and producing more or less complex graphs. And nowadays, those statistical packages might even possess web scraping functionalities. Some go even as far as to produce ready-made web development services like, for example, R-Shiny. Please note that here I'm referring to the full-service statistical packages, the ones providing all features available in data science. There are of course smaller packages like, for example, SigmaPlot, focusing on only a limited number of features. If you find the package you are using does lack in a given area, you have plenty of open source software available to cover that lack. So how do those tools differ? Well, differences might arise in the popularity of the packages. Some of them are extremely popular in a given industry or academic discipline, while the same product is not seen in another industry. Therefore, it is crucial to know which packages to learn for your target industry. Each of those packages has strengths and weaknesses. Plotting capabilities differ significantly between the packages, and the same goes for simulation or statistical testing. Another very important difference is the interface. I already stated that some packages are totally new languages, others have an easy click interface. And that directly relates to the time it takes to learn it. Availability is also a huge factor. While Stata has really good learning tutorials on its webpage, you might find it hard to learn MATLAB or Python. So now let's take a closer look at the most important ones and how you can use them. Excel, for example, has some limited statistical capabilities. Furthermore, it is great to do data capturing or plausibility checks with Excel. Nearly everyone has used it and knows at least the basics of Excel. While it is very limited in the more advanced functionalities, I would consider it as a basic tool which you need to be able to use as the data scientist. There is nothing more discouraging than when you get asked to create a simple modeling sheet in a job interview and you are stuck with that sort of task. So make sure that your Excel skills are up to date. Stata is a paid software which has command lines like a standard programming language, but you can also have a graphical interface, making it rather easy to learn Stata. Furthermore, there are excellent tutorials available at the Stata website. Stata is not domineering a specific industry or academic field like most of the other softwares. It can be considered a generalist tool which is well known in academia. Unless you know that your career path requires Stata skills, I would rather go with alternatives which have a more clear career benefit than Stata. SPSS is another paid software with an easy to use interface. There are several add-ons available for data mining, modeling or even surveys. Unfortunately, costs for the software, including some add-ons, can get quite high. What I see with SPSS is a popularity in universities. Nearly any university has SPSS on its machines. While this might look beneficial for the students at the first glance, I am personally skeptical about that one. It leads to the problem that most of the professors use this software to teach statistical analysis. Especially in the social sciences or biology classes, you will frequently encounter SPSS. It might be easy to perform statistical analysis with this tool. Chances are you will not work with SPSS outside of academia besides, let's say, survey agencies or probably in marketing. For a lot of data scientists, this can be considered the beginner's statistical package, which you use mainly during your educational period. Once you realize its limitations, including the small popularity outside of academia, you will need to take a look at one of the alternatives. We can also take a look at MATLAB and Octave. Octave is basically the open source sister of MATLAB. Both programming languages are extremely popular within engineering. Complex plotting is available as well as advanced simulation features. Recently I've seen MATLAB add-ons also available for algorithmic trading, but at the moment I would only strongly recommend it to engineers or people working on extensive simulation problems. SAS is another programming language which needs yearly license refreshment, which makes it a rather expensive product. Some universities offer free student licenses or workstations, but depending on your major you will likely work with alternatives like SPSS in university. SAS is widely used in a number of industries. If you want to join the pharma industry, I would consider SAS programming skills a must-have. It is still the only software accepted for FDA submissions of new drugs. If you search for SAS statistical programmer, you will see that most of those jobs are in pharma. Banking and insurances operate on SAS as well. It is their prime analytics tool. This is no surprise since SAS is around for quite some time and is well known for its quality and the plethora of add-on packages. You have data mining packages, web scrapers and much more to your disposal. SAS provides certification courses for SAS-based programmers, and those SAS consultants are also quite demanded on the job market. Overall, I think it is quite a good investment to learn SAS since it opens a lot of opportunities for your future. R is one of the go-to open source tools out there when it comes to everything related to data. It evolved over nearly 30 years and offers capabilities in nearly anything you can imagine. Plotting features as well as hypothesis tests are extremely well developed, since those are the core features of the tool. Especially since the RStudio team around Hadley Wickham is working to improve R and make it easier to use, R has seen a tremendous boost in popularity over the last years. Even data-related web development jobs are now possible with the Shiny library. Weaknesses in R might be in limitations when it comes to web scraping. The R Westpack is still not as mature as it should be. Furthermore, learning the programming syntax might take several weeks and can be hard, especially at the beginning. But overall, I would say it is a good investment of your time and energy since it is so widely used in nearly any industry. Users are daily updating the add-on packages, making R better each day. Python is another open source giant in the analytics field. Python is a multi-purpose tool that can do nearly anything related to programming. No matter if you want to compete in Kaggle or create a web shop with Stripe payment, Python can do that for you. I think investing time in learning Python is one of the best investments you can make. Especially data mining and web scraping work great in Python. Like R, it has a very supportive user community that is growing each day. However, if you do loads of hypothesis tests or pure stats work, you might find R a better choice. Learning Python might be equally as hard as with R, since both are totally new languages. We also have Mathematica, which is a paid tool especially used for mathematical research. Since mathematical notation is a weakness in many statistical packages, Mathematica is the go-to software to produce papers with high mathematical notation demand. Of course, Mathematica has standard features like plotting, statistical testing and data management, but I would recommend learning this language only for those who deal with theoretical math problems and math-related publications. Minitab is also a paid software which is most common in quality management and project management. If you are going for a Six Sigma certification, chances are you will encounter this software. Since Minitab has a convenient click interface, it's rather easy to learn and even available in several languages. The biggest problem with Minitab is the fact that it is not widely used outside of quality and project management. So unless you plan on going in those fields, it would be wise to focus on alternatives instead. Alright guys, so that was a list of quite common statistical packages, and I hope that this list is actually helping you in choosing the right tool for your career.